So the first part here is enter when crossing the EMA20. Okay, that part is easy. But do not enter while the EMA20 and EMA50 bars are flat and or tangled up. Well, so the definition of tangled up, Philip, I kind of need you to define that a little better. We can check in to see if the EMA20 and 50, if the moving averages are flat. That's simple enough. We can use a slope indicator. But tangled up, you can't be subjective like that, with computers. So that basically needs to be, that definition kind of needs to be tightened up. Yeah. So, all right, yeah. So Philip is saying crossing over each other repeatedly, in a short amount of time. So the question is, how do you know that it's going to keep crossing each other? How do you know? I mean, we can see in the past whether something is crossing itself, once it's occurred. But how do you know, like for example, right here, how do you know that is not going to be, that's not going to continue to move up? How do you know, how are you able to predict the future that it's going to keep crossing back and over again? All right, so hopefully you can see why using subjective terms like that really is difficult, when you're trying to convert that into logical conditions. Yeah, so Philip, here's additional information is I need to know why this is a no, because both of your moving averages are sloping up. So how do you know that that's a no-go, without hindsight, right? Obviously, you can tell in hindsight maybe that's not good. Well, actually, that does look like a good entry in hindsight, but I guess what I need to know is why, what is the logical condition here that tells you that this is a no-go versus, entering on this point here. All right, so Philip is saying, maybe when there's a increasing gap between the EMA20 and 50. Yeah, okay. Yeah, I think we can do that. All right, so next thing is I have BloodHound on my chart, so we're going to use the button up here at the top of the chart to open up, right, the BloodHound interface. And then the next thing you want to do is put a file name in here, right, so that way your work gets saved to a file. So I'm going to use the change button here, and I'll put in today's date, and there we have it. All right, so we have a file name in here that all of our work will get saved to now. Okay, so I'm going to start working on the logic board here. And to do that, we're going to click New, and then that makes a new, logic template for us. So the Renko EMA20 and 50 trend system, something like that. There we go. And let's see, I do need to get a couple of indicators on here as well. There we go. All right, so we just need a couple of EMAs. All right, so here's our EMAs, and let's see if we can find a real consolidation area. All right, well, we have a little bit to work with here. So let's see. All right, so the first thing we'll start with is, checking for, basically relatively flat areas on the EMA20 and 50, right? Check for flat. And then we can check for that separation as well. All right, so let's get BloodHound back open. All right, so to identify, if your moving average is flat, flat-ish, right? No moving average is really ever truly flat, but they get kind of relatively flat-ish. We're going to use the slope solver here. So let's give this a name. So this will be the EMA20, and we're basically now let's see. We're not identifying a flat, but we're identifying when there is enough of a slope. That's what we're looking for, is when there's enough of a slope. All right, so there's a name here, and then next let's put in the EMA20. So there's our EMA. Change it to 20 period, and there we go. All right, so as we can see, there's always basically some kind of a slope on the EMA, right? And we can tell because there's always a long or a short output, right? So what we need to do is, there we go, is we need to use a minimum and maximum slope parameter. And you'll notice that on a chart, slopes can only be measured in points or ticks, right? Yeah, so the Renko bricks and the ATRs, don't really apply here. Well, I guess they could, but yeah, when you're measuring the slope of something on a chart, you can't measure it in degrees because I could do this, and now everything's flat, right? But is it really flat? It all depends on how you decide to scale things, right? So degrees is subjective when it comes to charting. So instead, you're measuring the slope of something by how much it moves up or down on the price, right? So that's why slope is measured in either ticks or points. So on a bar to bar, that unit is always 1. But regardless of how you squish the Y scaling, the amount of movement is still the same, right? It's just optically looks squished. So the trick here, the first key is to kind of identify what you would consider flat-ish in your trading here. So I'm going to start with some low numbers here. So usually with a moving average, I think somewhere around 1/4 of a tick is usually a good starting point. Something like that, right? And we can now see that already there are a few bars, right, where there's no output. And so basically that means that the indicator is flat. It's less than 1/4 of a tick of movement here. So 1/4 of a tick doesn't seem to be enough, so let's step it up to 1/2 a tick there. And so there we go. So now 1/2 a tick, right? We have a few more bars where things are kind of flat. And let's bump this up again. Let's do 3. This actually might be too much here. 3/4 of a tick. And yeah, there we go. So that we can see, right, that's a little more dramatic there. So let's leave it at 3/4 of a tick here, and see what happens here. We'll see what happens. Maybe this needs to be increased a little bit more, and definitely, this measurement is going to change, depending on the instrument, right? So each instrument has a different amount of volatility. So you'll notice that, and also it's going to depend on the price movement, right? So as each instrument moves differently, right, the moving average will move differently. So so there's no way to find a setting that works across all the instruments. Since all the instruments have that different level of volatility, this slope amount is going to change from instrument to instrument. Okay, so there's a slope for the EMA20. And so next, let's make one for the EMA20. So what I'm going to do is I went to my Solvers tab, and I can select the EMA20 slope, make a copy of it right there, and then adjust the name and go in and adjust the period. So it's now a 50 period. And there we go. I just made a slope solver for the EMA20, right? Cool. So now let's go back over to the logic tab here, and we're going to go to our solver nodes, existing nodes, and so there's the 20 and there's the new EMA20 that I just made. So let's put that on the board, connect that up, and there we go. Alright, so now we can see what 3/4 of a tick looks like on the EMA20, right? It just basically wiped out this whole area and considered it flat. So with a larger moving average, you might want to move the tick down a little bit. So let's go down to maybe half a tick, something like that. There. Yeah, maybe something like that's a little more appropriate. And then we can start putting both of these into a AND node. Right? Basically, yeah, there's the combined results right there. So, and so basically it's a matter of kind of fine-tuning this part of the process, right? So maybe the EMA20, isn't important. Checking if the EMA20 is flat. You might find out that checking the EMA50 slope, might be removing a lot of good opportunities. So you might, just leave this disconnected like that, and maybe only use the EMA20, something like that. So it will take a little bit of, testing and fiddling around, which is exactly what BloodHound's for, is to kind of fine tune, hone your system in there. So, but for now, we'll go ahead and leave it connected in like that. All right, the next part, as Philip suggested, is maybe check for this gap as well, a separation between these two moving averages. And to do that, we can use a comparison solver. Right, so we'll compare the EMA20 to the EMA50. And the comparison solver does not calculate the separation, but you can put in a difference amount or a separation amount, right? So difference, separation, same thing. So you can check to see that there is a minimum difference or separation between two plots here. So we can do something like that here. All right. So what we're going to do is compare the EMA20. This might be too much, but I'll start off by checking to see if there's 2 ticks of separation between the EMA20 and the 50. Right. Okay, so now input A will be the EMA20. Pretty straightforward. Like so, and then input B will be the EMA50. Like so. And let's put in that 2-tick separation like so. There. Alright, so yeah, there we go. So Yeah, I guess 2 ticks is okay to start with. You know, you might end up going to 3 ticks later on. Let's see what 3 ticks looks like. Yeah, so 3 ticks really kind of wiped out this whole area here. So yeah, what the heck? Let's leave it at 3 ticks, and if we don't get any results, then we can knock this back down to 2 ticks of separation. So now, if I connect this all together, right, basically there is our filtering right there, right? So I think really what Philip is looking for is basically these little pullbacks here where, you know, where, grab that again, right, where there's this separation between the moving averages and also, you know, a decent angle or slope on the moving averages as well. So, all right. So let's see. Let's call this and node our filters here. So, or our EMA filters. There we go. Something like that. So, Philip, I don't see a specific entry. So, is your entry basically like on a pullback bar? Yeah, so I'm thinking maybe your entry is something like this. Let's see. So, I'm going to grab a inflection solver here, and we'll just take a little peek at this and see if this looks like what you're imagining. So on Renko bars, you know, we can set up basically a price inflection, or basically a inflection on a chart is just a reversal point, right? So on a chart, you can't inflect from left to right, but only up or down when it comes to charting. So, let's set this to price, and I'm going to reverse the output. Yeah, there we go. So something like that. All right, so there we go. All right, so let me take a look and see what Philip has written to me. Let's see, so the entry is at the dip crossing the EMA. Okay, so it looks like it would be this point on the chart down here. Does that look correct? Let me see here. Yeah, right there, like these 2 points where the bar crossed below the 20 and then crossed back up. Or are we talking back here, the crossing back here? So enter at the EMA20 line. Okay. All right, yeah. Let's see here. Well, we don't have any entries here. Okay, no entries there. All right, so let's disconnect this there. We probably won't be using that solver there. And so I'm not sure if, yeah, if this would be appropriate or not. Let's see if I can find some better spots here. Well, yeah, at least with oil, the problem I'm seeing is every time price comes back to the EMA20, the EMA20 is flattening out. But there is a good separation there still. So, yeah, even in your screenshot here, the EMA20 is flattened out. Yeah, you know, so making sure that the 20, you know, aren't flat. You know, the problem is that the 20 is flat right there. Yeah, whenever whenever price pulls back to that EMA20. All right, so let's see. Let me see what Philip has for me. Let's see. The pullback is only for an exit signal. Okay. Yeah, so he said, yeah, enter at the EMA20 line. But then you're calling these pullbacks the exit. So sounds like I'm getting conflicting information here. I'm not. So I guess let me ask, would this be the entry, you know, at the EMA20? Let's see, two different BloodHound signals, one for LE and one for LX. Let's see here. Julie's suggesting, can I show him an EMA20 inflection? Sure. Yeah, we can do that. Let's see. And Philip, if you could explain what LE and LX are. I'm usually not too good with abbreviations. And you'd be surprised how traders use abbreviations so differently. So one bad thing about the trading industry is terminology is just all over the board. Now if you're a doctor, there's one word for one thing only, right? But when it comes to trading, man, the terminology, like there could be 10 things meaning the same thing. So it's horrible that trading has such broad terminology that traders use. So all right, so let me show an inflection of the EMA20 here. So all right, so I'm going to put this back to indicator value, right? So the input type, I put it back to indicator value, and then I can plug in the EMA20. There. All right, so there are basically reversal points of the EMA20 there. Yeah. So while you guys are looking at that, let me see what Philip has got for me. All right, Philip saying, oh, perfect. All right, Philip saying entry would be at 350. Great. Let's get some of these marked here. Okay, right there. Great, we got one right there. And I'm guessing that one would be the entry. And probably, 446. So, right there. Okay. Well, I think, so I think the price inflection actually was correct. So let's go, put this price inflection back the way it was, and let's put the outputs back to the default there, right? So I'm guessing it's basically going to be where the green stripe is, and I'll adjust the arrows there. Oh, long entry, long exit. Gotcha. Okay, thanks, Phillips. All right. So I think we're getting there. So there we go. Now, all right. So our first one, was stripped out. So let's see what's going on here with our first entry. There, right? It's probably the difference between the two EMAs probably too great. Let's take a look here. So, so what I just did, right, is I took this solver. Remember, so this is our comparison solver, and if you remember, I increased it to 3 ticks, and so 3 ticks is a little too much right there. So let's maybe knock it down to 2.5 ticks. Let's see what happens here. 2.5 ticks there. There we go. All right, so 2.5 ticks did it, and so we can see that here on the signal bar, you know, we basically have a long output there. Right. So let's see if we get a signal there. Yeah, okay, good. So now we have a signal there. All right. Yeah, so as mentioned, you know, really fine-tuning, you know, basically the separation between the moving averages and fine-tuning the slopes, you know, here is going to be the key to kind of getting this all to work. So, all right. So with that, let's actually, let me go back there. All right. So this is obviously, you can see this is going to generate a lot of signals here. Right. So every time that we basically get a reversal bar and there's enough separation and the EMA20 is not flat, right? So you might need some more, let's see here. Yeah, we might need to increase the slope amount on the EMA20 here. You know, so if you're kind of interested in trying to strip out those signals, something like that, let me just kind of show you here on how you would play around with this. Okay. So we're going to select the EMA20 slope solver here, and let's just increase the 1 tick of slope, and we'll see what happens. There. All right, so we still have this signal down here, and one of these was removed. So at least we got rid of one of those in that area. And so maybe if we go to 1 1/4 tick of slope. Yeah, and that was a little too much because it removed our first signal down here. Right. There we go. So 15/100ths worked okay. All right. Yeah, 15/100ths, and there, and it stripped away the signals right there as well. Right. So again, kind of, you know, fine tuning, you know, the slopes and the separation there should get you, you know, what you're looking for. So. All right, so I think we have the entries here. Probably as far as we can go today. All right, and so Philip, once you've kind of had a chance to kind of look at this and everything, you know, this will probably help you realize, you know, other requirements that you need, you know, for your entry signals here. And so once you've kind of developed those other kind of conditions to, you know, maybe filter out some unwanted signals there, you know, then you can, email those back in, and we can revisit this again, revisit the entries. So, all right, so now let's work on the exit signals here. Yeah, so pretty simple here. Create an exit signal on the first down bar, but only after, you know, only after X up bars here. So I'm just thinking in my head how to overcome this problem here. You know, counting the number of, you know, up bars is pretty simple to do, but the problem is that all of these additional entry signals are going to reset the counting, though. Yeah, so when we get an entry signal, right, the entry signal itself is going to tell the, so here's how you go about. You would use the signal counter, right? yeah, use the signal counter. And we could set this up in such a way that it counts, that it counts up bars. So we count the number of up bars, but of course we need to tell the signal counter when to start counting, and that's obviously the entry signal. So we tell the signal counter start counting from the entry signal, but then it gets to another entry signal, and that tells the signal counter to start counting again. So it starts counting up bars, and then it gets to another entry signal, and it resets. Right, so every time we get to an entry signal, it's gonna reset the signal counter to tell it to start counting again. So it doesn't look like that's really going to be possible. Yeah. Right. So now you can probably see that. Looking at this chart, right? You're just focusing on what you see the entry, but as you can see, BloodHound shows you basically where your entry signals are true everywhere. So you can see, right, that there's lots of different entry points based on your criteria. Yeah. All right. Well, let's go ahead and build the exit signal, but just understand that, it's not going to work perfectly if we get an entry signal, that's less, before the counting is finished, right? So, all right. So with that understanding, what we're going to do is we're going to make a copy of our logic here, right? We're going to make a copy of this logic template because, as I mentioned, we need the entry signal to know when to start counting from, right? So we actually need all the logic for the entry signal here. So we're going to hit copy, and then rename this here. And let's see here. All right. So I'm going to set this exit up to count 4 bars. Because my chart is a 5 Renko. So 5 Renko bars is going to be 20 ticks. Yeah, so we need at least 4 bars. And then, let's see. Oh, yeah. All right. I was just thinking that we could just simply, that we would get enough up bars in a row. But let's see if I can find an example. Okay. Yeah, so this example right here, we get basically 1 up bar, and then a down bar, and then we need to wait for a bunch of more up bars here before we get an exit signal. So, all right. Yeah, I was thinking I could do something really simple, without using the signal counter, but we definitely need to use the signal counter. Yeah. Oh, and let me go back to this previous one and yeah. There, I'm just going to rename our AND node because the AND node's no longer just the EMA filters, right? It actually is the signal as well. Now that we've plugged the inflection solver into it, basically what's coming out of this AND node is the entry signals there. So there, I'll just rename that. And then switch my logic templates and rename this too. There. Let's see. All right, so the entry signal is basically going to be used as a reset here. So let's zoom in a little bit, right? So, right, yeah, so every time there's an entry signal, we need to start counting from that point. And so, yeah, so we're using a reset signal here to reset the counting. Yeah. All right, and so now, what are we actually counting? Well, we're going to be counting the up bars here, or down bars. So we're going to use basically just a bar direction, right, like that. So yeah, there we have it. Simply put, all right, we want to count all the long outputs here, because the long outputs are the up bars. But also, we do need some filtering here. Right. So we only want to count, well, actually, no, that's not true. Yeah, I'm thinking that we probably only want to count, you know, the up bars, you know, when our EMAs are, you know, set up correctly for a trade. Well, yeah, I don't know, maybe that is true. Because I guess when, you know, if the bars kind of enter a consolidation mode like that, you know, those bars really don't count. So, yeah, yeah, so let me just kind of point out here that, yeah, so counting the number of up bars isn't going to create a 20-tick profit target. You know, so for example, let me see if I can find a good example. Yeah, here we go. Here's a good example. All right. So let's take this entry here, right? So we count one bar, so that's 5 ticks, and then we get a down bar, and then we count the next bar, but that's the same 5 ticks. So if we're counting bar 1, let's see here, yeah, so if this is bar 1, and then we get bar 2, right? Well, basically bar 1 and bar 2 are the same 5 ticks. So counting bars, you know, obviously isn't a perfect solution. You know, the only real way to the only real way to get a 20-tick profit is to use a profit target. Yeah, is to use a profit target. So, you know, BloodHound, BloodHound is not designed to calculate your profits. You know, BloodHound is for designing the entry and exit signals here, you know, as you have. But BloodHound is not a measuring tool, so it's not gonna measure where, you know, a 20-tick profit target would be. Yeah, so just be, you know, just be aware that counting bars isn't going to get you a guaranteed, you know, 20 ticks or you know, whatever ticks you want, because as soon as there is a down bar, then you introduce, you know, an error in that logic. Yeah. So, but let's just go ahead and build this out just for the sake of learning here. You know, so if you do want to count the number of up bars, we would do something like this. Right. So what we have here, let's see. Yeah. So what we have here are, you know, bars, up bars that are valid, right, after an entry signal. Right, so for example, on this up run here, right, we get our entry signals, and then we can see all of the up bars, right, are identified. And so we can now count all of every bar that has a long output. We can count that. So we can plug that into the counter. And let's see, what are we counting up to? Let's see. I think we need to count up to 5 because we need to include the entry bar. Right? I think we need to include the entry bar, but we'll find out here in just a moment. And then the look back bars, probably 15 ought to be enough. And then let's see, the output style, let's put that on digital. All right, let's take a look here. So let's see. All right, so this is the entry bar. So this would be bar 1, 2, 3, 4. So actually, you'll want an exit signal on the 4th bar. Yeah, because that'll get you out, all right, at the open of the next bar. And so that distance there, right, so that's 20 ticks. Yeah. So we can knock this down to just counting 4 bars. And then I'm sure we probably only need to count, like, look back 10 bars maximum there. And there we have it. So if you want, if you want a nice clean looking exit signal, actually we're not done quite yet. This is not the exit signal. Because if you notice, it's giving us a long output, right? So if we're in a long trade, you need a short output to exit a long entry. Right, so we need to do one more thing here. We're going to reverse this. Or basically, we're going to swap it. There. There we go. All right, so there's our short signals that Raven and Blackbird will use as an exit signal for a long entry. Right there. There. And then if we really want to look nice and tidy, we don't really need to clean this up. You don't typically need to clean up your exit signals very much because they're used to exit a trade, right? So as long as let's just kind of take a look at all this here, right? So if you're out of the trade here, right? So we basically exited the trade right there. Well, if you're flat, then there's nothing left to exit. So these other exit signals don't do anything, right? If there's no position open, then an exit signal just doesn't do anything, right? So you don't really need to kind of clean this up if you don't want to, but for the sake of human eyes, people like to see things nice and clean, nice and cleanly. So we could apply a signal blocker to this, and that would clean it up here. So let's see here, probably 15. We go 25 bars just for good measure. And on the signal blocker, if I'm going to use the signal blocker, I need to take the entry signals to basically reset the signal blocker, right? Because if you notice, right? We get our exit signal here, but then after this next entry signal, right, there's no exit signal anymore. And that's because the signal blocker is blocking. And here we can show that by doing something like this, right? So you see all this little output here, this short little outputs. So this is telling you that the signal blocker is actively blocking, right? So therefore we don't see the exit signals, right? Here we don't see those exit signals. And so what we need to do is the signal blocker, it needs to get reset, right? So I'm using the reset connector here. We need to use the entry signals to reset the signal blocker. And so what we need, we need reset opposite signal. There we go. So as soon as I enabled the reset opposite signal there, now we can see, let's see, sorry guys, I just had a little warning beep there go off somewhere. All right, so back to the exit signals here. Yeah, so there's our entry, exit, entry, exit, entry, exit. Yeah, we didn't have this entry marked, but that's our entry and exit. Right, so there's a cleaned up version of the exit signals there. All right, so just a little tip on the signal blocker. Using this blocked output here is very helpful when you're setting up your signal blocker. All right, if we look at this closer here, right, we can see that the signal blocker, come on, let me grab that, there we go. The signal blocker is turned off on these bars, right? We can see that this blocked output here that I set to 0.2, right? So we can see when the signal blocker is actively blocking, and then when the signal blocker is no longer blocking, right? So we can see that when we get to our entry signal here, right? So the arrow's marking the entry signal bar, right? It's turning off the signal blocker. So with the signal blocker turned off, we can now get the next exit signal, and then the other exit signals are basically being blocked until we get to the next entry bar, right? And then the signal blocker turns back off and then it turns back on. Right? So yeah, so just remember, yeah, if you need to use the signal blocker, using this blocked output just to help you set things up is very, very helpful. And then when you're all done, we can just turn it back off. Just set it back to 0, turn it off, and now we have our clean looking entry signals. So there we go. All right, so let's take a recap here of what we did. Right. So to count, X number of up bars, we're using the signal counter, and we basically designed a logic to identify the bars that we want to count, right? So we have a bar direction, which is just telling us simply, whether it's an up bar or down bar. But then we also plugged in our entry signal filters here, right? So these solvers here are the EMA slope and the separation, right? So this is our EMA filtering, that was used for the entry signals. So we combine the EMA filtering with the bar direction, and we basically have bars to count. Right? So this AND node here, is identifying which bars we want to count, right, as the up bars when there's a long signal there. And let's see if we should get the opposite. Yeah. So here we go. Right. So if we have the opposite condition here, right, we can see it's identifying the down bars to start counting. Right. Right. So there we go. So these are the bars that we want to count. We plug it into the signal counter, and we want to count up to 4 bars. 4 bars after. 4 bars after the entry signal. Well, we have a look back period, so you gotta tell the computer, how far back can we look when we want to start counting. So, and also with the signal counter, right, we have the entry signals, and so the entry signals have to basically restart the counting. So the signal counter starts counting when it gets an entry signal, right? So that's going into the reset there. So we're counting, right, the number of up bars, and our output, right, it was a long output, and so we had to use a long short modifier to swap, or basically reverse, the long output into a short output. Right, let's take a look here. Yeah, so again, right, so the signal counter, right, it's counting long outputs, and so to use that as an exit, we simply needed to reverse the output there. So if I connect that in, right, reverse it to a short. So now it's actually an exit signal for a long trade. And then we just use the signal blocker to clean things up, right? Just to give us a nice human-looking, clean exit signal. So, again, the signal blocker is not necessary. So we could just go with that and call it good. So. All right, so there we have it. There's our little summary of the exit signals. Okay, let's see here. So Philip is saying don't exit at 4:38, but do exit at 4:45. Let's see here. Okay. Oh, sorry. Yeah, you know what? On the first down bar. Geez. Yeah, all right. I totally skip this one critical part here. Yeah, so we want to exit on the down bar. Okay. All right. So let's do a quick redesign here. Yeah. Okay, so we can take the raw signal counter signals here. Yeah, so we can take the raw signal counter signals, and actually, let's see here. Yeah, I'll just leave those off to the side. I don't think we're going to use this at all, but I'll keep it there just in case. And so now, right, we have a short output, but we need to isolate it to just the down bar. There, right? So, simply put, we could take, yeah, all right, so I have a bar direction solver already, right? And if I connect that in, right, obviously when we get a down bar, we get a short output from the bar direction solver. So I can combine, right, I can combine the bar direction with our our counted bars, right? Our signal counter output here. And there we go. There. So that, yeah, that would be the correct exit signals. Yeah, just to note again that when you get a reversal bar too soon, that it is possible that you may not get a 20 tick minimum exit signal. Right? So each of these reversal bars, these bars in the opposite direction, every time one of those happens too soon, right, it's going to mess with the distances. So as explained earlier. So yeah. But there we have it. So that should probably work most of the time.